5.6 is titled Using Multiplicative Inverses to Solve Equations. Okay, and that's a pretty fancy way of saying just getting rid of the fractions, okay? So, there's a little thing there about caves. Stalactites are icicle-shaped stone formations found on cave ceilings. They form from minerals deposited by dripping water. Suppose a stalactite is 10 inches long and is growing at a rate of 1/8 of an inch per decade. How long will it take for the stalactite to reach a length of 1 foot? Okay, so that's one of the kind of the things that we're going to do. So let's go and read the beige box in the middle of page 253. So the product of a number and its multiplicative inverse is 1. Okay, so let's go ahead and just jump into the example number 1 and see what we're talking about here. So example number 1 says, solve this guy. Okay, so we're trying to solve this guy. Okay, so let's say that I had, instead of this, I had this. Okay, so let's see if we can solve this guy here first. Okay, so AJ, how would I solve this? How would you solve this guy here? 2x is equal to negative 12.
Let me see. So 4, 7.
Not this guy here.
Oh. That divide.
You divide both sides by 2, right? Because this guy here is 2, right? So you're going to divide it by 2. The 2's would cancel out, and you'd only have x here, and you would have this, right? This is how you would normally approach this question, right?
Yeah.
Well, this is the same thing here, okay? I have this guy here, so I'm going to go ahead to get rid of that. So to get rid of this guy, I'm going to divide by 4/7. I'm going to divide both sides by 4/7. Okay? And we've found that we've said that dividing a fraction is flipping it over and multiplying it, right? So we're going to start with 4/7 x, and we're going to multiply it by the flip here, like that. And over here, I'm going to do the same thing. I'm going to multiply. Okay. So this 4 and this 4 cancels out. This 7 and this 7 cancel out. All you have left is the x. And that's what we were trying to accomplish. Okay. Over here, you have a negative number times a positive number, so it's a negative number. Then you have 12 and 4, so this is 3, 21. Okay. So you ended up multiplying this side by the multiplicative inverse, which is 7/4. Okay, which in essence, what you've done is you just divided it by the fraction in front of here. That's all you really did. Okay. So this is a fancy way of saying we're dividing it by this fraction. Okay. So that's the approach that's shown in the book. Okay, or kind of shown in the book. Okay, I'm going to give you one more way to tackle this. Okay, another way to look at this is to say that I have, okay, so I'm going to go ahead and try to clear the fractions. This is what I'm going to do here now. I'm going to go ahead and clear the fractions. What can I do to clear this fraction, to get rid of this fraction, or get rid of the 7 underneath? I can multiply everything by 7, correct? If I multiply everything by 7, now this 7 cancels out, and I have 4x is equal to negative, I don't know, this is what? 84. Okay. Now I have something that I started with earlier. Now I can just go ahead and divide by 4. And these 4's cancel out, and I get x is equal to negative 21. I get the same answer. It's a kind of a two-step approach, right? I'm multiplying it by 7, and then I'm dividing it by 4. When we used the multiplicative inverses, what we did was we multiplied everything. We multiplied this guy by 7 over 4. So we multiplied by 7 and then divided by 4. That's the same thing we did here, right? So it's a one-step approach versus a two-step approach that we just did, right? So now the 7's cancel out, the 4 cancels out, all I have left is 7. Okay? All right, it's the same thing. All right. So that's example number 1, and let's go to example number 2. Example number 2, we have negative 11 over 15, x plus 4 over 5 is equal to 1/3. Okay, so it's kind of the same thing we had before, except we have this guy here now, right? Because if I take away this guy, it would be the same thing we had in example number 1, right? But now I've added this. Okay, so then the first thing we need to do is get rid of this by subtracting it from both sides. If I subtract it from both sides, I get this guy, because this guy goes away now. All right, so I get this guy. Okay, now I have to do what? I have to combine the denominators, right? Or better yet, what I can do is I can multiply both sides by the common denominator and just totally get rid of the fractions. Okay, so I'm going to multiply this guy by 15, and I'm going to multiply this guy by 15, which is the common denominator. Okay, so now this 15 cancels out, I get negative 11x. Over here, I'm going to do the 15 in here, I get what? I get 15 times 1/3 is 5. We're going to multiply this guy. Okay, so this is a little complicated. Let's do the inside. Let's go ahead and start from here. Okay, so let's go ahead and start from here. I'm going to multiply everything by 15, right? So I'm going to multiply this guy by 15. I'm going to end it with negative 11x. If I multiply this guy by 15, I'm going to get this times 15. And over here, I'm going to get this guy by 15. Okay, I already started with this, and I'm going to multiply this guy by 15 also. I'm multiplying this by 15, this by 15, and this by 15, because 15 is the common denominator between 3, 5, and 15. Now the 15 cancels out, negative 11x, plus this 5 here, I get 3, so 12. 5 and 3, I get 5 here. So 5. Now this is a much easier thing to deal with, right? Because I have no fractions now. We're back to something we dealt with in my chapter 3 or something like that. Now let's go ahead and divide. Let's go ahead and now subtract 12 on both sides. This guy cancels out. I get negative 11x. It's equal to 5 minus 12, which is minus 7. 11 is going to be equal to negative 7 divided by negative 11, because I'm dividing by negative 11 here. Negative times divided by negative is a positive. I end up with 7 over 11. Okay? Again, I started with something that's pretty messy, but by multiplying by the common denominator, I end up with just all integers, no fractions, and I deal with it that way, right? Okay. Okay, in example number 3, we'll go ahead and try to solve that stalactite question that we had before. Find out how long it'll take for the stalactite to get 1 foot. Okay, so I'm going to start with 10 inches. Right, I'm starting with 10 inches. Then every 10 years, I'm going to add 1/8. Okay, so this is the number of decades, right? And I want that to be equal to 1 foot, which is 12 inches, right? So again, I'm going to go ahead and subtract everything by 10. So I'm going to get minus x is equal to 12 minus 10 is 2. Here, I'm just going to multiply everything by 8. Because now that goes away, I have only x left. X is going to be equal to 16 decades, right? 16 decades. Okay? Okay, that's good. And oh, we're all done. We're all done. So let's go ahead and look at your homework assignment here. Your homework assignment for this guy. Okay. So